This video is on the topic of kinetic energy and using the kinetic energy equation. If an object is moving, it has energy in its kinetic store. This car begins its journey with energy in the chemical store of the fuel. As the car begins to move, energy is transferred into its kinetic and thermal stores. As the car brakes and stops moving, energy is transferred away from its kinetic store into its thermal store due to the friction of the brakes. When the car is stationary again, it has no energy in its kinetic store. At the end of its journey, the car has less energy in its chemical store than it did at the start because some of the fuel has been used up. So what is kinetic energy? It's the amount of energy in the kinetic store of an object. An object has energy in its kinetic store only if it is moving. When the object stops moving, energy is transferred away from the object's kinetic store. The amount of energy an object has in its kinetic store is dependent on two things: the object's mass and the object's speed. Although we talk about kinetic energy when we're using the equation, always remember to use the energy store terminology when answering worded exam questions. Let's take a look at an example exam question. An aircraft accelerates from rest along a runway. At takeoff, the aircraft has 3.0 times 10 to the 7 joules of energy in its kinetic store. The mass of the aircraft is 11,000 kilograms. Calculate the speed of the aircraft at takeoff, and that's for 3 marks. So we're given the amount of energy and the mass of the aircraft, and we're asked to calculate the speed. From these variables, we know that we need to use the kinetic energy equation. So the first thing we do is write it out. We're calculating speed, so we need to rearrange the equation to make v the subject. Whenever we rearrange equations, there are 2 rules we need to follow. Whatever we do to the equation, we have to do it to both sides. And to undo an operation, we use the opposite operation. So the first thing we need to do here is cancel out the 1/2. Multiplying by 1/2 is the same as dividing by 2. So to undo that operation, we need to do the opposite. We need to multiply by 2, and we need to do that to both sides. These 2's cancel out, leaving 2 times the kinetic energy is equal to mv squared. The next thing we need to do is cancel out this m. V squared is multiplied by m, so we divide both sides by m. These m's cancel out, leaving v squared is equal to 2 times the kinetic energy divided by m. Now that we have v on its own, we need to unsquare it. We do that by square rooting both sides, which leaves us with v is equal to the square root of 2 times kinetic energy divided by m. So here is our equation. The first mark is for the rearrangement. The next mark is for substituting the known values into the equation. You can think of equations as templates that tell you where to put the numbers. So we've got 2 times the kinetic energy, which is 3.0 times 10 to the 7 joules. That's divided by mass, which is 11,000 kilograms. And that's all square rooted. That's the second mark. When you plug this into your calculator, you get v is equal to 73.85 meters per second, which rounds to 74 meters per second to 2 significant figures. And that's the third mark for the final answer. Always show all the steps in your working out. There are marks available at different stages in the calculation, which you still may be able to get even if you make a mistake. In summary, kinetic energy is the amount of energy in an object's kinetic energy store. The amount of energy in an object's kinetic store is determined by 2 things: the object's mass and the speed at which it is moving. When performing calculations using any equation, always show each step of your working so that you can still get some marks even if you make an error. Don't forget to check out all our other fantastic revision resources here at Save My Exams.